The focus in the 1980s was very much around sulphur. Sulphur was the biggest cause of acidification, but it was rapidly realised that this was a more complex problem, and especially the emissions of nitrogen, both from nitrogen oxides from road traffic and power stations, and also the ammonia mainly from the agricultural sector. These were contributing to a number of different problems. One of them was the acid rain problem. So both ammonia and NOx emissions contributed to acidification, so they had to be taken into account in the protocols. But also the nitrogen deposited on sensitive ecosystems of biodiversity importance, this nitrogen would cause changes in the vegetation and loss of important species. And so this was another impact which we've looked into here and contributed to the European work on how to minimise those impacts. And then nitrogens are interesting in another way, in that it's one of the precursors of ground level ozone formation. So this ozone is one of the most important regional pollutants. It has impacts on human health, and it also reduces crop yields and impacts on other vegetation as well. So we moved from the acid rain debate, looked into the impacts of nitrogen deposition on a European scale, and then looked at the impacts of ozone on crops on a European scale as well, and developed some tools and models which could better understand and estimate the potential yield losses due to ozone. As the scientific community and the policy community understood that it was a more complex situation, there wasn't just one pollutant, one impact, but there were many pollutants involved in many impacts. The protocols that were developed in Europe became more sophisticated, and the last protocol under the Convention on Long-Range Transboundary Air Pollution was signed in Gothenburg in Sweden. And this was a multi-pollutant, multi-effect protocol. So it did respond to the scientific information that we had to deal with this in an integrated way to get the optimal result.